Everyone, so in the last class we discussed two basic principles, addition principle and multiplication principle. Today we are going to talk about the arrangement and the selection, or in the other words, permutation and combination. So recall the definitions if you have already seen. A permutation of n objects and n distinct objects is an ordered arrangement. Whenever we talk about the arrangement, we are concerned with order without repetition. So arrangement, order and no repetition. If it is an R permutation, it means we just need to arrange R objects out of n objects. In case of the combination, it is unordered selection and without repetition. So repetition with repetition we'll discuss in the next class, but in today's class we are only going to see without repetition. The standard notations are PNR or CNR, but sometimes you also use these notations also for PNR, CNR. But first, how do we derive the formula for PNR and CNR? So we start with PNR. So let's assume that there are n objects, n distinct objects are there, and we need to choose two objects where order matters. So we need to arrange two objects out of n. So when we need to arrange, then out of n, the first one has n choices and the other one has n minus 1 choices. If I have to arrange 3, then n, n minus 1, n minus 2 and so on. This we have already discussed in the previous class. And if I have to choose r objects, then it becomes n, n minus 1, so on, n minus r minus 1, which is same as n, n minus 1 and n minus r plus 1, and I can multiply it by n minus r factorial and divide it by n minus r factorial, which becomes n factorial by n minus r factorial. So very simple formula. So P n r is equal to n factorial by n minus r factorial. Now if I have to compute CNR, so see the difference between PNR and CNR. It is a difference of order only. In PNR, AB and BA both are different, but in CNR they are not. It means that, or if you see the three terms ABC, then ACB, then BAC, BCA, CAB and CBA. All these six are different. But in case of CNR, they all are same. So it means that we have 2 divided by r factorial if r objects need to be arranged to obtain the CNR. So CNR is PNR divided by r factorial, which becomes n factorial, r factorial and n minus r factorial. So please do remember these formulas. Now let's see some questions. The first question says that how many ways are there to arrange 7 letters in the word systems? It means there are 7 letters which need to be arranged. It means order matters. So first it is a problem of permutation. The next thing is that the obvious choice is, someone can say that it is P7, 7, which is 7 factorial. But this is actually not correct, because here all letters are not distinct. If they are distinct, then it is 7 factorial. If they are not distinct, then you can see that in the first 2 positions and this S, so this is first S, this is second S, this is third S, this is second S, first S and this is third S and so on. So all these solutions would be same because these 3 letters are same. For other 4 it's fine. It means that the approach could be, I must arrange the 4 distinct letters and then the remaining position would be filled by 3s, which means I must arrange out of 7 position only 4 positions and the remaining would be arranged or filled by s. It can be seen in this way also. If there are 7 positions, then for example E, I have 7 choices. For M I have 6 choices. For T, because no repetition, for T I have 5 choices. For Y I have 4 choices. Yes, and then the remaining would be filled by S. So this would be same as 7 multiply 6 multiply 5 multiply 4. The next question says that how many of these arrangements do the 3s appears consecutively. So I want to put all 3s together. If I have to put all them together, I should consider as one letter only. So now there are only 5 letters, 3s, then T, E, M and Y. 5 letters are there, so therefore 5 positions are there, 5 comma 5, which is 5 factorial. So moving further to the next question, which says that how many different 8-digit binary sequences means sequences made up of 0 1 with 6 ones and 2 zeros. Whenever you start with, always think that the order plays a role or not. So in this case, for example, one of the solution is 3 1 0, then again 1 and 0. So these 3 ones have nothing to do with the order, whichever one you put. If all these numbers are distinct, then the order matters. Here the positions of ones and zeros matters. It means that there are total 8 positions and you need to fill either 6 position first and remaining 2 positions would be filled by zeros, or you fill the 2 positions first, remaining 6 would be filled by ones without considering order, which means the answer 6 8 comma 2 is same as 6 8 comma 6. Why they are same we will discuss in the coming classes, but remember that this is the result and they are always equal. Now we need to form a committee of K people, which need to be chosen from 7 women and 4 men. We say that, let's discuss one by one. So how many ways are there to form a committee with 3 women and 2 men? Now again, all men and all women, order doesn't matter. When you say that this committee has 2 men and 2 women, so either men 1 men 2 are there, or men 2, either it is M1 M2 or it is M2 M1, doesn't matter. The men's are different, objects are different, but the order doesn't matter, and that's why it would be 7C3 multiplied by 4C. Any positive size, so 0 is not allowed, but equal number of men and women. So what are the possible cases? Now the cases would come into the picture, and therefore addition principle would come into the picture. So please do try all these problem by yourself. So 7Ci multiplied by 4Ci. So 7C1 multiplied by 4C1 plus 7C2 multiplied by 4C2 and so on. So multiplication principle is there, but at the same time, since there are 4 cases, so addition would also come into the picture. Committee has 4 people and one of them, one is fixed and which is a male, Mr. has been used. Yes, and 4 people. So now what need to be done? We need 3 more people, but for these 3 people there is no restriction. They can be men, they can be women. So out of total 11 people, 10 are remaining, and out of 10, 3 need to be picked. At least 2 are women. So at least 2 are women. Again you can see the case, 2 women, 3 women, 4 women. That's it, because we need only 4 people. So 7C2 multiplied by 4C2 plus 7C3 multiplied by 4C1 plus 7C4 multiplied by 4CG. That's it. Now in this case, another approach is you first pick 2 women out of 7 women, and then it is saying that So 2 is there, and then you pick 2 people from the remaining people. So which means that the other approach could be 7c2, and then out of the remaining people, which is 9, you pick the 2. Is it correct or not? Think over it. Give some time and think that is it correct or not. So this is what I have discussed. Now in this case it is not correct because repetition would come. For example, you pick 2 women, W1, W3. Order doesn't matter, which means W3, W1 is same as W1, W3, but all women are distinct. And then you pick 1 woman and 1 man. Now in the next case, I pick 2 other women, W1, W2, and then pick 1 woman and 1 man. Both the cases are same. Repetition occurs, and that's why this approach is not correct. But the approach which we used is, we first pick 2 women, because at least 2 women are there, and then the remaining are there. Then so I just pick 2 women and I say that the remaining 2 are men. So W1, W2, and then M1, M2. In the next case I pick 3 women, W1, W3, W2, and then some men. In the last case I pick 4 women. So you can see that all the cases are disjoint, and that's why there is no chance of error. The last, how many ways are there to form the committee? If committee has 4 people, 2 of each sex, and Mr. and Mrs. Baggin cannot both be there on the committee. So to address this problem, you need to see that how many different cases are there. So the first case is Mr. Baggin is there, but Mrs. Baggin is not there, and I need total 4 people, 2 of the same sex. So when Mr. Baggin is already there, it means out of the 3 people I just need 1, but out of 7 women I need 2. Sorry, out of 6 women I need 2, because Mrs. Baggin cannot be included. In the second case, when Mrs. Baggin is included, then out of 6 women I need only 1, but out of 3 men, because Mr. Baggin cannot be there, I need 2. The last possibility is both cannot be there. When both cannot be there, then out of 3 I need 2, and out of 6 I need 2, when both cannot be there. Yes. Now can there be the another approach? So another approach is again straightforward. When we say that we consider all possible cases, and among all possible cases we subtract the cases when Mr. and Mrs. Baggin are there in the committee. So all possible cases are 7c2 multiplied by 4c2, and subtracting when they are there in the committee. So 6c1, because Mrs. Baggin is there, so remaining women are 6, and 3c. Okay, few more interesting question. It says that how many arrangements of the 7 letters are there? Yes, similar question we have done, but with the condition that E occurring somewhere before M. Think over it, spend some time. So E occurring somewhere before M. So for example, E and M, this is allowed, but M and E, this is not allowed. Now if this condition is not there, E is occurring before M, and if I have to put E and M first, then the total possibilities are 7 positions are there, and out of these 2 positions need to be filled. But now you can observe that EM is allowed, with a gap, but ME is not allowed, which is same as looking is this, that order is fixed. Both are not allowed, EM and ME, which means that instead of P7, 2, I should consider C7, 2. Yes. Now 3S need to be filled in the end. So 2 more letters are there, but there the order matters. So multiplied by P5, 2. Okay. So interesting question, interesting approach. Let's see one more question. This we have already discussed. So a manufacturer plant produces ovens and an inspector marks acceptable A or W. How many different sequences of 15 A's and U's are possible in which third U appears as the 12th letter? So again a condition is given. So now it is a problem of combination, because order doesn't matter. When I say A, it doesn't matter. I have to fit the positions of A and U, but with the given condition. So now what the condition is, that 12th letter is U. It means in the first 11 letters 2 U are there and the remaining portion will be filled by A. This is 12th, then 13, 14, 15th. 13, 14, 15th, what can be done? What are the choices? Each can have, both is allowed, either A or U. It means that 2 cross 2 cross 2, so 2 cube, which is the required answer. So in the next class we will see permutation and combinations with repetition. Thank you very much.